So we're told an acidic buffer solution is formed when 10 centimeters cubed of 0.125 mole per decimeter cubed aqueous sodium hydroxide are added to 15 centimeters cubed of 0.174 moles per decimeter cubed aqueous HX. The value of Ka of the weak acid HX is 3.01 times 10 to the minus 5 moles per decimeter cubed. Calculate the pH of this buffer solution at 298 Kelvin. So we're given Ka, which hints that we need to use Ka in our calculation. And we're calculating pH, so essentially we need to find the concentration of H+ ions. So our Ka expression requires the use of our concentration of H+ ions, and we need to calculate that essentially. So what we do is rearrange the formula, so cross multiply and then divide both sides by x minus to get H+ is equal to Ka times our concentration of Hx over x minus. And what we do, we're given Ka, that's 3.01 times 10 to the minus 5, and we need to calculate the concentration of Hx and the concentration of x minus. So what we do first is calculate the moles of everything we're given in the question. So let's calculate the moles of NaOH. So moles of NaOH, and that's equal to the concentration times the volume. And we want the volume in moles per decimeter cubed, so we need to divide by 1000 afterwards. So 0.125 times our volume, which is 10 over 1000, and that's equal to 1.25 times 10 to the minus 3. And then we can calculate the moles of Hx, so that's moles of Hx, and that's equal to 0.174 times 15 over 1000, and that's equal to 2.61 times 10 to the minus 3. And notice that we have an excess of Hx, so we also need to calculate the moles of Hx in excess. So that's Hx in excess, and I'm abbreviating Sx as xs, and that's equal to 2.61 times 10 to the minus 3 minus 1.25 times 10 to the minus 3, and that gives us 1.36 times 10 to the minus 3. Now in our calculation we're going to be using both our moles of NaOH, so this one, and our moles of Hx in excess here. So now next what we do is calculate the concentrations of each. So the concentration is the moles, so let's just write concentration of NaOH, and NaOH is basically the X minus or OH minus. So X minus concentration is equal to 1.25 times 10 to the minus 3 over our total volume, which is now 25 because we put these two reagents in a solution together. So our total volume is 25 centimeters cubed, so 25 over 1000, and that equals to 0.05. And then we do the same for our Hx, so Hx concentration is equal to 1.36 times 10 to the minus 3 all over the total volume, which is 25 over 1000, and that gives us 0.0544. And now that we've calculated our X minus and Hx, we just simply put these into the formula to give us H+. So H+ is equal to, I'm going to write up a bit here, I'm running out of space, is equal to Ka, which is 3.01 times 10 to the minus 5, times Hx, which is 0.0544, all divided by our X minus, which is 0.05, and you should find that gives you 3.27 times 10 to the minus 5. And to get pH we just do minus log of the hydrogen ion concentration, and that's equal to minus log of 3.27 times 10 to the minus 5, should be a minus there, sorry, and that gives us 4.48. So to give it to two decimal places, pH is always given to two decimal places, And yep, that's how we calculate the pH of this buffer solution.